let's, as a little bit of context, let's start talking about some of the solutions that people have brought out there. And the first person that we're going to hear from is Russell, and Russell is as a member of the PowerCorp staff for the last 10 years. PowerCorp is clearly one of the leading organizations in the world implementing not only wind diesel technology, but power systems for remote communities, ranging from systems in Europe to systems in Antarctica. So truly spanning the globe from a power sector side. Russell has extensive experience. His bio is in your packet, so I won't belabor the points. But Russell has extensive experience in the deployment of wind and renewable-based power systems, and he's going to talk about the experiences that PowerCorp has had primarily in the Australian market looking at renewable technologies. So as I pull up your presentation, Russell, come on up, if I can figure out how to pull up your presentation. Okay. Russell.
Fantastic. Thank you, Ian. Good morning, everybody. I clearly am Australian. I hope you can stick with me with the accent. I'm learning yours, so we'll see how we go. Our apologies from our Managing Director, Alan Langworthy, many of you would know or know of. He had hoped to be here this week. Unfortunately, it clashed with other things that he had planned. He's always enjoyed coming to Alaska and Canada and Northern America for these conferences and doing work up here. So also thank you to Kat and the committee for putting this together. Amazing attendance at yesterday's pre-workshop get-togethers. I was astounded. The rooms were full. It was standing room only. So, and again today, I don't think there's too many spare seats in the house. So very fantastic to see the industry growing. I'll see if I can control this thing. Here we go. So just quickly before I fill you in on what we've been up to, if you weren't aware of PowerCorp or who we were started by Alan Langworthy, the guy I mentioned earlier. He's a geologist by trade, but a real person who believes in renewables by heart. And he was the first person in Australia to build a house that solely ran on renewables. And we found this article on the internet only just a year or so ago, and have publicly embarrassed him since. So he's still got the same funny beard as in that photo, and he's been a great mentor for those of us that have joined his company since, and the company's now been going for 23 years. So that didn't really come out that well on the screen, but PowerCorp's, interestingly enough, whilst been doing wind diesel projects and most recently even solar diesel projects, we've also been asked to do quite a lot of consulting over the last few years to talk to people about with our experience, what could they do, and I apologise for the resolution there, but what could they do to put renewables into their systems? And people have come to us, which was strange and new to us, and we've had to adapt and learn how to take on that requirement and that demand. And it's been quite healthy for us to take an objective point of view and talk to people about what they could do with their site. It's not necessarily wind, it might be other forms of renewables, or it might be a better way of controlling their load to reduce their fossil fuel consumption. That said, there's a short list there of some of the renewable energy, well actually no, that is the full list of wind diesel projects that PowerCorp has done, ranging in size and location around the world, and largely in Australia. The bottom two that are in yellow that haven't come up that well, you'll hear about more detail this afternoon from my colleague Will Galton. And they are solar diesel, interestingly enough, which is, was a nice change, something different for us to look at in the idiosyncrasies of solar. It was not as easy as we would like to have thought. Scattered around Australia, the projects are largely coastal, of course, the wind ones. The small triangles throughout the top there are diesel-only systems. There's a lot of systems up there. They're remote systems. Our headquarters is actually up here in the top of Australia, in a place called Darwin, and those systems are now starting to look at implementing solar. Unfortunately, wind isn't as available as here is in Alaska, with the wind regime very poor. in that central part of Australia. So all these wind projects around the west coast of Australia have been where we've mainly focused when we've been doing wind diesel. Likewise, we've done some down here in Antarctica. I'll expand on those there, as well as some up here in Portugal and out in the Indian Ocean as well. And lastly, what does Power Corp's history look like? Where did we come from? We came from a diesel environment predominantly, which may sound a bit surprising. We actually see it as a strength. We actually understand the diesel power station, and at the end of the day, that's what everybody else seems to understand. It's what the people living in these places are relying on currently, or will rely on when the wind stops blowing. So we came from 100% diesel automated systems, automating those in remote areas in Australia. And then over the years we've implemented wind and most recently solar, and increased the penetration levels we've been able to achieve over those times. So I'll go through a couple of the projects just quickly for you. This project's over here on the west coast of Australia, a place called Denham. It's a World Heritage site, very tricky site to work in whilst looking after all the issues that are restricting any construction works in a World Heritage site. We installed 3 at that point, but now 4. The most recently installed an additional 4th wind turbine, all Enercon machines, 330 kilowatt E33s into the diesel grid there. That was our first diesel project, wind diesel project, sorry, we'd done, initially just with 1 machine, and over time added more. The system now runs in the order of 50 to 70% instantaneous wind penetration, depending on the load, and with annual fuel savings in the order of 40%. So at the end of the day, they're saving 40% of their fuel bill they were saving a couple of years ago before the system went in. And as fuel prices go up, as Ian said, this is a great thing for their community. In Australia, that community is in fact managed by a utility that looks after this half of Australia. That's one state for Western Australia. So that utility is responsible for many, many power stations in that state. So where they can reduce their costs, that helps them make more money available for the other sites that are not so fortunate to have wind, I guess. Another one down here, this was a big one, a place called Esperance in the south of Western Australia. Quite a large location, quite a large minor centre, minor town. 2 wind farms were installed over a period of time. The existing investors' machines were there before we were involved. They were quite old and becoming a little bit unreliable, so the part of the project that we were involved in was to help with the upgrade and the refurbishment of those machines, installation of the Enercon machines, and integrating the whole system into the large diesel power station. So that was a great project. 11 machines in the power station there, and the idiosyncrasies of working with those big generators was something new to Power Corp at the time, and the limitations that those generators were applying on us with minimum loading, start times, minimum temperatures that they didn't want to go below. I guess I was talking with someone yesterday and they said, have you guys done any work with waste heat capture? And we said, yeah, well, we have. However, we're kind of robbing from Peter to pay Paul. If we put these great wind turbines in and start saving fuel, then inherently the diesel are doing less work, therefore they're generating less heat. But that's okay because we're making electricity out of the wind. And up here in Alaska, I can see that that's prime. The experiences I've had up here where I've seen power stations where they do capture the heat and they do pump it around the community and try and make best use of it. It's an interesting challenge, and we face it, and I'll talk about it a bit sooner I think it's the next slide, where we actually created electrical heat loads on purpose so that when the wind was blowing, we would run these electric power electronic boilers to upgrade their heat loop electronically rather than using diesel. So it was a funny mindset to get our heads around that, okay, we're going to save fuel, but we're going to increase the load. Okay, that's what we've got to do. So once you get it, it starts to sink in. So yeah, this was a crazy one in Antarctica. It's a long way away from Darwin. Where we live in Darwin, the average ambient temperature in Fahrenheit doesn't move far from 100 degrees. In Antarctica, it's much similar to these sort of temperatures. So a company from Darwin, it was quite strange that we would be involved in such a project. I guess by that point we'd done quite a few wind diesel systems, so this was one that seemed to make most sense. Once again, the Enercon machines, they were the only company who wanted to do the wind turbines in Antarctica due to the extreme temperatures and the extreme wind. It's actually almost too windy down there for wind turbines, and we don't have the problem of low wind events. We actually have quite a lot of high wind events where the machines have to shut themselves down to protect themselves. So we did some great things there. We created the heat loop electrically, as I mentioned. That became our spinning reserve, so we actually didn't run with a spinning reserve calculation anymore for those technical guys in the room. We used the heating loop as a spinning reserve. As soon as the wind dropped off, we'd turn the heat loop off really quickly and maintain stable power supply. And the wind averages there are fantastic. You know, it's 90% instantaneous wind for days at a time. And then annual average in the order of 70 to 80% fuel savings. So in a pristine environment like Antarctica, if they can reduce their fossil fuel consumption, it's got to be a great story. This was a strange one we did in Flores in the Azores, which is in the middle of the Atlantic Ocean. It's managed by Portugal, it's part of Portugal. It was a worldwide tender. We had no prior knowledge of the project coming out. Generally speaking, we've had a knowledge of projects before they come out, and then they finally come to tender, but you're already fairly aware of them, and generally that happens. This one just turned up on a website, popped up on our emails one day. We put a tender in and won it, and which was great. It was a wind, hydro and diesel system where they wanted to integrate wind and, well, they already had their wind, they had their hydro, and everything was really unstable, so they just turned the wind turbines off, which really wasn't a good business case. So the role that we took over was to integrate them by installing this flywheel thing. I won't spend much time on it, but it's essentially a stability box. It's got a very short amount of storage, spins it up to 4,000 RPM. I think I've got another slide here talking about it. It's got 18 megawatts seconds of energy stored in it, so it'll absorb or inject energy as required to just sort out those little instabilities in the wind or wherever the fluctuations are coming from, so that the diesel and the hydro will all work together. And yeah, that's turned out to be a great project. That site runs really well now. They're able to run both forms of renewable and reduce their diesels completely. For the electrical people in the room, this is essentially how it works. That this is the grid or the mains, whatever it's connected to, comes through an inverter, converts to DC, back to AC, and then they've got a flywheel bolted on the end there, and it's kVARs and kilowatts. So we jumped out of Antarctica straight into the desert of Australia. A place called Coral Bay. Whilst it's on the coast, it's quite a hot location. And this was an interesting one. It's in a cyclone zone, and historically you can't install conventional wind turbines in these locations. So these locations are destined to always burn diesel. Well, it turns out not to be the case. Those machines in the top there are a French machine. They're a two-blade downwind machine. A company named Vernet builds those, and they were the first of those machines installed in Australia. They tilt down. I'm not sure if I have a picture or not. Doesn't matter. They tilt down in a cyclone with a manual operator. A person goes out there and holds a finger on the button for 45 minutes, and they slowly make their way down. And it's been a great project for both that town and the utility that now runs that site, because prior to that they had no options. They would only be running diesel forever because there was no wind turbines prior to that available in Australia that would be appropriate to put in such a location of a significant size. I'm not sure if I can go back. They're a 275 kilowatt machine. They're site rated to 200 kilowatts due to the ambient temperature, but the site only has about an 800 kilowatt load, so we can get reasonably high levels of penetration even at maximum load. So the fuel savings are great. We actually had some fun and games when we installed it, where the operator thought that all the fuel meters were broken because they weren't logging enough fuel consumption. And we're like, well, go and look at the wind fuel meter and you'll see that it's probably spinning pretty fast. Worked out to be a really well The site has containerised diesel generators, which was the preference of the client. That's okay, that's how they wanted to do it. It's an interesting challenge. I'm not sure if it's fully adopted up here or completely ignored. As it's turned out, the client's now regretting they took it on. The ocean's about another half a kilometre from this location, so every surface around these machines has a nice fine layer of rust on them now. So they're out there. The guy that runs the power station doesn't have to run the power station. He's forever on rust repair. So I think they're thinking of potentially building a building over the whole lot and only having 4 surfaces to worry about instead of many. That was enough of Australia, and then we went back to Antarctica, which was great. And this time I personally went down. I'd never been there before, and I guess it surprised me, but it probably shouldn't. That last night I met a couple of people in the room. Oh yeah, I've done a few seasons at Antarctica. I was like, wow, you know, this place is quite popular, but it is an American base, so I guess it's highly likely, and it's got a similar climate to Alaska, I guess. The Americans are down there. Most countries are down there. A lot of countries are down there. And in this case, there's an American base and a New Zealand base quite close to one another. It's McMurdo Research Base, operated by the National Science Foundation. And it's a big setup. I'm not sure, for those of you that were here yesterday and heard me talk about it, I apologise, but it's a big show, and right next door, 3 kilometres away, is their little New Zealand show. So there's about 12, or potentially up to 1,200 people in the American base doing science research type things down there, and then there's a maximum of 60 people in the little New Zealand base next door. And the Americans have got ice runways they've had for 50 years. The New Zealanders have got little tractors and little toys they play with. So New Zealand felt quite thankful and had really appreciated the efforts of the Americans helping them out like a big brother all these years. So the New Zealanders came up with the idea of connecting the 2 bases together with a cable and installing wind along that cable. And so it was a New Zealand project for the better of both sites. PowerCorp was the integrator there. Once again, those Anacon machines turned up because they were already rated for that environment. And this is called stage 1 of that project. There'd be a few people in the room familiar with it, I'm sure, and those guys that have been down there. But it's an amazing project. It's really, really interesting. For example, on this side, they're running at 50 hertz, which is the New Zealand and Australian standard. Of course, on this side, they're running 60 hertz, the American standard. So there had to be a magic box installed to convert the frequency between the 2 systems. They've got 6 in that picture, but I think it's now up to 8 diesel generators on the American side, in the order of 1,400 kilowatt machines, big Caterpillar engines. On this side, there's 3 200 kilowatt little things in the New Zealand base. But the New Zealanders could not be happier. They're so happy with the outcome of this project, and I believe the Americans are also happy. The fuel savings are starting to become apparent. This was 330 kilowatt machines installed, so up to 990 kilowatts, just under a megawatt. So they can see up to 50%, 50 to 60% of their instantaneous power now provided by the wind, and the wind's reliable. Yesterday we actually went online and had a look at the site whilst I was talking, and just for a change, the wind turbines were going flat out. There was, I think there was 14 metres per second of wind passing at the time. The graphs were showing that it was just flat out and had been flat out for a week or so prior. So there's every likelihood that the project will proceed to stage 2 with the agreement of both those parties, and they're expecting to put in another 13 wind turbines because there's a lot more heat load that's not yet accounted for. The heating load is currently done by burning diesel or burning oil, and Kat's just giving me the hurry up. So yeah, they're talking about putting 30 more machines in and other flywheel systems as well, which helps stabilise. So 3, 4, 5 more of those yet to be determined. Fantastic project. Wind diesel, exactly the same as what we'll be talking about for the next few days, but hooking 2 sites together, interesting challenges of frequencies and whatnot. The last thing I'd just mention is, this is not in Australia. This is a job we've just picked up with Hydro-Quebec in Canada. It's a consultancy to look into the possibility of installing wind diesel at this location. It's called Madeline Island, and it's an exciting place. It's There's 13,000 people that live there. The wind regime looks fantastic. Capacity factor in the order of 50%. So we'll be looking into a study or a consultancy for them to determine what the likelihood or what the business case for installing wind is there. I think the load range is anywhere from 11 megawatts to 40 megawatts. Initially they're looking at about a 6 megawatt wind farm. So that's an exciting one for wind diesel. Hopefully we'll be talking about that at the next conference, that it's since been progressed to construction. And I think there's a lot of people watching that one in Canada. It's quite a high profile site. I believe it's a popular tourist location for Canadian people and people from Quebec. So we fly actually from here over there after this conference to go and talk to them about it. And that's all from me. So hopefully I'm on time, Kat. Thanks very much.
Any questions? Please come up. Feel free to use the mics if you have a question about some of their experience. So I'll start off with a quick question. You've done a lot of different work, both in completely new power systems where you come in and do the whole thing, as compared to retrofits, coming in and applying the technology on top of an existing power system. Can you give us a little insight on the pros and cons to doing either one?
Interestingly enough, we came from a retrofit environment, and generally they are still the larger percentage of our projects. The retrofit environment has a lot of challenges. You're working with older diesel engines, maybe older control systems, certainly a lot of preconceived ideas of how the existing system can run, preconceived settings on all the parameters of the power station, the protection. And that's a real challenge, managing those expectations, those historical practices that have been in place. That I think we find to be truthful, that whilst they're challenging, they're quite fun, they're quite interesting to talk to these clients and understand what's important to them. Why do you run this engine always with that one? Because they work really well together and they're both yellow. You know, when you get down to that level and then you go, okay, and then they look at themselves and they go, well, we might be open for other ideas. So, because like I said earlier, we came from the diesel background, and at the end of the day, the diesel still has to do the work if the wind doesn't turn up that day. Likewise, when we do the greenfield sites, then you get everybody with an interest, or everybody with a favourite thing they always wanted to do. You know, in our old power station, we didn't have this, so we really want 2 of those in the new one. Okay. And then we want one of them. Are we going to have any room for the diesels? Well, we'll extend the building and put them out there. You know, so we've had some really interesting experiences working with both retrofitting and greenfield sites. I think it's probably more challenging with the retrofitting. You're working with a system that's probably running while you're installing gear into it. So you've got a live generator just here while you're working on this one to set it up so it can be integrated with the wind farm. You've got to keep the power on at the same time. The people in the town don't want you to shut their power station down for 2 months while you upgrade the system. So that's certainly the more challenging of the two, but interesting, both the same for sure.
Any other questions? Okay, I have one more. I mean, I can always come up with good questions, especially for PowerCore. Currently, you have a lot of technology, flywheels, the low-load diesels, but you still don't operate with diesel off. Why, and are you thinking about changing that?
He didn't tell me he was going to ask these questions. Okay. We have done diesel off mode with a couple of sites, and my colleague this afternoon will talk about the most recent ones with the solar. I was going to save the story for tonight. We've got the dinner thing happening tonight, but I might tell it now. Essentially, it comes down to the client. The technology does do diesel off mode, but the clients are generally very nervous. And to be honest, the savings between running at high penetration with a diesel running, maybe they're burning 5 to 10 litres of diesel an hour where they used to burn 100, 200 litres an hour. the confidence that gives them knowing that their old friend, the diesel's running in the corner, versus the savings of that extra 5 litres, the customers generally don't want to go for it. The other problem that comes with that is the fault ride-through capability. If there's a fault on the distribution out in the community, say a car runs into a pole and the power line falls on that car, there's a real problem there with feeding that fault with enough energy to blow fuses or blow circuit breakers, and there's a real risk you could leave the power on and therefore leave that car live if you are running in a diesel off mode and not providing enough fault current. So it's quite challenging to go that last little step between running with a lot of wind or a lot of renewables and very little diesel to then going with completely no diesel. That said, we did get a phone call about probably 12 months ago now from the site that I showed there in the Azores. They rang up and they said, oh, we're running in diesel off. And we said, oh, okay. Not sure the system's really set up to do that. You guys have been mucking around with the parameters, I guess. And I said, no. What happened was we were merrily going along, and the fuel ship turned up. And when he delivered the fuel, he delivered so much fuel, it wasn't possible that we could take that much fuel. And we worked out, because it's an unmanned power station, that we actually hadn't been running the diesels for a week because we'd run out of fuel. But because no one goes there, because they're very relaxed in Portugal, I think the operator probably got in trouble. I think he's supposed to go there. They worked out and they had a look at the graphs, and sure enough, the engines all ran out of fuel about a week earlier. The fuel ship had run late, or something had happened to that effect, and the wind and the hydro and the flywheel just kept doing their thing, and no blackout. And so they rang up to tell us, and they were all excited, and they regularly do this on purpose now. They regularly go, okay, well, it looks like the load's good, let's shut the diesels down, and away we go. So the technology is certainly there. There are still the challenges there with fault current, and it's very real, and it needs to be taken seriously on a site-by-site basis. We need to do the model of the grid to see that we can or cannot provide enough fault current. We talked a little bit about it yesterday in the workshop, that maybe synchronous complicators or synchronous motors are useful for that. There's a lot of different solutions you can use there, but with the client's permission, we'd certainly be keen to have a go. And in fact, I believe in Ross Island they're thinking about it, but that's probably a few years out. So.
Sorry to put you on the spot.
That's
okay. Okay, one more question and then we'll move on. Hold the little key down for a few seconds and the light should come on.
I wasn't sure if I understood exactly how it works, but you mentioned something yesterday about there being postage stamp rates in Australia. So I was wondering if that was part of the reason why you might not, there might not be as much incentive to pull every little bit of diesel off the system, because at a certain point, the trade-offs between reducing your fuel use and the risk of maybe having a system of blackout, you're operating on a much bigger. You just don't have the same kind of incentive. Do you think that's a factor in the penetration levels?
Yeah. So in Australia, it is fixed price tariffs. Each state of Australia fixes the price for electricity. So the people of, for example, Anchorage pay the same price as the people on the North Slope for electricity in their house, which I'm sure if that was adopted in Alaska, the people up there would be super happy about that. In Australia, that is the case. So you're right, there's certainly no financial incentive whatsoever to reduce the fuel consumption anymore, because they're already losing lots of money. It's about security and reliability. In Australia, they have regulators, external regulators, watching the utilities to make sure that they provide the correct frequency, the correct voltage, that they don't have outages for more than 1.5 times a year. Has anyone worked out how you do half of an outage? Essentially, I believe that's half of the town. So if the utility goes outside of these very strict rules, then they pay a penalty in money to this external regulator that is privately funded only from penalties. It's not funded by the government. So that regulator is driven to pay their own wages by penalising the utilities when they do things wrong. So it's quite a harsh environment. So the utilities err on the side of safety. We're quite lucky that they actually even consider installing high penetration systems when the risk is there that you're running quite close to the edge. Maybe under some scenario there could be a blackout and that could cause the risk of a failure. So what they do is they pass the risk on to us. During construction and the following 5 years we have penalties. If they have a blackout, they charge us, and then I think they use our money to pay their fee to the regulator. So it drives us to make sure we build gear that works. But yeah, that fixed price tariff is certainly a challenging and interesting one in Australia.
Right.
No worries.
Thank you so much.